Hi, my name is Huling, and I am actually writing down the calculations that we did during the experiment.
I'm Brendan, I was the cameraman and recorded the experiment. I'm Cooper, and I analyzed the measurements and couple calculations.
Hi, I'm Ivan. I'll hold up the black background and the ruler.
And I'm Ronald. I did the ball dropping. Our time frame for this is Wednesday, May 15th at 6 p.m.
Okay, so about the coefficient of restitution, that's also known as E. It is a number which indicates how much kinetic energy is saved after a collision of two objects. So, for example, if the coefficient is really high, for example, it's close to 1, that means that very little kinetic energy is lost in the process. But if it's very low, that means a lot of kinetic energy was lost in forms of other forms of energy, for example, thermal or potential energy, right? It is important because it tells us whether or not a collision is elastic. So if it's elastic, it has a very high E. If it's very low, then it has a very low E. It is relevant whenever we are considering collision, such as in safety equipment, sports equipment, car accidents, and other things like that. So we normally think of this ratio as between 0 and 1.
Alright, so the way that we did this experiment, we selected a slab and a ball, and for each of them, we picked our ruler and we picked the initial height, and we dropped the ball from that height. We'd have the video in slow motion so that after the bounce we could record the second height, and with all the second heights and then third heights and so on, we could calculate using the coefficient of restitution equation and take its average, and that's how we found all of the equations for corresponding ball and slab.
Hi, I'm Ivan. Our group goal for this lab was to get the most accurate coefficient of restitution for all our balls. The best combination that we predicted was deriving and aluminum, and the reason for that is because it was a hard material and it's also light. And the worst combination that our team predicted, was neoprene and aluminum. And the reason for that is because neoprene ball was soft and it just absorbs impact. Thank you.
Okay, so for this experiment, our group chose the first one is the deriving ball plus aluminum base. Our second one is the neoprene ball and the aluminum base. The third one is the nylon ball and the acrylic base, and then the fourth one is the wood ball plus the acrylic base. Our maximum was the deriving ball plus aluminum base, and our minimum was the neoprene ball plus the aluminum base.
So a source of error that could have affected our experiment include the fact that the camera as well as the ruler were not perpendicular to each other, so that could have created a slant, and by the person looking at the video, it might have seemed as if the ball is not jumping at the correct height that it should be. Another source of error was the fact that the ball was dropped by hand and not by an equipment. So because it was dropped by hand, that was an angle, so the ball didn't drop perpendicular to the ground, and that could again have affected the height that the ball reached at the end.
So some discrepancies in the experiment between the theory and the real life experiment are the surface that we were bouncing on likely wasn't smooth, so that could cause the ball to bounce in weird angles. Some other discrepancies that could have caused are outside forces besides just gravity and the normal force. So when the ball bounces, it's getting pushed a bit to the side, causing it to bounce at a different height than it would, just because it's not a perfect drop that we can't possibly ever achieve. Also, the ball not being round and perfect could have affected the drop height and how it bounces, because it could bounce in another direction or absorb the force in a way we weren't expecting.